All right, you guys, we're going to go over this assignment. It's called 6.9 Review. We're going to be looking at a bunch of different integrals and stuff, okay? All right, so let's see. Let me just write these down as we go. Okay, almost always, especially if it's not like a quotient or something, I'm almost always going to try to do u sub if I can't recognize right away what it's going to be, right? And you guys, this is u in here. So I'm going, okay, u is 2x squared plus 1. The derivative of that, du, is 4x dx. And I know we've talked about, you guys like to go, how do I turn a 3 into a 4? 4/3. And so on the outside becomes 3/4. Okay, so what I have is I've got 3/4, and then there's a 4x, and then all of that to the 1/3 dx. Okay, so here's the thing. I'm going to replace that with u. And then if you guys look, 4x dx means I can erase this, and I can erase that, and I can replace it with a du. Okay, so I end up getting 3/4. When I do an integral, I'm adding 1. So I get 1/3 plus 1 would be u to the 4/3 divided by 4/3. And when I'm dividing by 4/3, I'm multiplying by another 3/4. Okay? So my final answer here, if I multiply these straight across, is going to be 9/16 u to the 4/3 plus c. And I'll just go ahead and put u back in there. Okay. Okay, nice. Let's see. The next one we've got, looks like another u sub question. Now this one is a little bit of a trickier u sub. We talked about u sub questions like this. Okay, in this case, I'm going to let u be 2t plus 1. And then du is 2 dt. I don't have a 2 there, so I'm going to put in a 2 and a 1/2. And I'm looking pretty good here. So I've got 1/2, then I've got square root u du. Now the problem is that there's this extra t right here that wasn't replaced with something else. Okay, and that's when we have to do the kind of, I'm going to say like tricky u sub is what I call this, right? So we come up here, take this, and I go, okay, well, if u is 2t plus 1, then 2t is u minus 1, then t is u over 2 minus 1 over 2. I think that's an okay way to write it. That's probably how I'll write that. Actually, no, I think I'm going to write it a little different. U is u minus 1 all over 2. Okay, and that is what I'm going to take and put right here now. Okay, so give myself a tiny bit more space. So t is turning to u minus 1 over 2. Now what I think I want to do is I want to go ahead and take this 2 out here with that 2, so I have a 1/4. Makes this a little bit cleaner. I'm going to go ahead and distribute my square root u through there. Now I'm still in the integral sign. U to the first and u to the 1/2 gives me u to the 3/2. 1 times the square root of u gives me u to the 1/2. So at this point is where I'm actually going to take the derivative, okay? So I'm going to go 1/4. Sorry, actually take the integral. When I take the integral, I drop off the integral sign in the du. This becomes, if I add 1, u to the 5/2 over 5/2, just times 2/5. And then u to the 3/2 over 3/2, which is times 2/3. You can distribute through the 1/4 if you want. You certainly don't have to, but you can. Let's see here, the 2 and the 4 will cancel out and give me 1/10 u to the 5/2. And then right here, same thing, the 2 and the 4 will cancel out and give me 1/6 u to the 3/2 plus c. And at the very end, I just go back up here. I saw what I let u equal, 2t plus 1, and I just put that right here. Okay, and there's my, so that's what I call tricky u sub, where you just have to like figure out how to deal with the extra term that's on the inside. All right, perfect. Okay, for our next one. Yeah, this I'm definitely going to do split the fractions. So we talked about one of our methods when you only have a single term on the bottom is just called split up the fraction. And the way that I'm going to split this up is I'm going to say, okay, if I do 3x to the third over x squared, that gives me 3x. If I do 2x squared over x squared, those cancel out, that gives me 2. And then if I do 9 over x squared, that gives me 9, and I'll go ahead and bring that up, x to the negative 2. And then this is just a very straightforward problem, okay? 3, the integral of x is x squared over 2. The integral of 2 is 2x. And then the integral of this, now remember guys, I'm adding 1. The integral is x to the negative 1 over negative 1. And so I think I'll write it like this, 3 over 2x squared minus 2x. I'm going to put these together and put minus 9 over x plus c. All right, that's what I get for that one. Okay, perfect. Let's see if I can get fit number 4 right here. Oh yeah, this is a fun one. Okay, guys, what is, what's 5 squared? That's just a constant, right? 5 squared is 25. And so if I integrate this, what's the integral of 25? It's just 25x. Okay, so I feel like that was just kind of making sure we were paying attention here. All right, nice. Here we go. Okay, I'm thinking that there is 2 different ways that we could do this problem. Actually, no, there's only one way we can do this problem. I was thinking that there was 2, right? What I was thinking was I could either complete the square on the bottom. And when you complete the square, it turns it into inverse tan form. Or if you could factor the bottom, then you can do partial fractions. Okay, I'm going to try to talk to my process so that you guys understand like how I'm deciding how to do these. And so I was like, oh, cool, I could do this 2 different ways, but I don't think I can because there's nothing that multiplies to make 18 that adds to make 6, right? 18 is 1 times 18, 2 times 9, 3 times 6. I can't actually factor that, okay? So I'm going to say, all right, actually, no, I can't do that. So I have to do completing the square and putting it in inverse tan form, okay? All right, let's complete the square off on the side over here. So the first thing I do is I move this out. Then I go like this, right? Half of negative 6 is negative 3, squared is plus 9. Since I'm doing a plus 9, I do a minus 9. And then this factors to x minus 3 times x minus 3. So that's x minus 3 squared. And 18 minus 9 is plus 9. So that's what I'm turning this into. Dx, okay? And what I notice is this is now inverse tan form. All right, this is inverse tan form. Do you guys remember that this 3 out here can just be taken out? So I could just move that out, call that a 1. Okay, and then remember in inverse tan form we have, okay, u is the variable, so that's x minus 3, because it's x minus 3 squared. Du is dx. And remember we have to find a, and right here, a is whatever squared makes 9, and 3 squared makes 9. Now, I want you guys to remember, for inverse tan, you do have to go. Okay, so it's the integral of 1 over a squared plus u squared du, whichever way, whichever way the a squared and the u squared are, that doesn't matter. It's 1 over a inverse tan u over a. That's what I'm drawing this from. That's what you got to memorize, okay? So this is, oh, there's a 3 out front. Don't forget about that. 1 over 3 inverse tan x minus 3 over 3. Okay. And I can see right here that like my 1 and my 3 cancel out. So it just ends up being inverse tan of x minus 3 over 3 plus a constant. Okay? Nice. All right. That was a good one. Let's check out number 6. So a lot of times when I have a fraction and it's like the same, I don't know, like degree or whatever, like the same kind of thing on the top and on the bottom there. There we go. Okay, I'm going to do u sub, but I'm going to let u be the thing on the bottom. U is going to be sine y minus 2. And du, the derivative of sine, is going to be cosine y dy. Okay? And this is what we call, when I put this back in, that's going to be 1 over u, and then cosine y dy will be du. This is what we call ln form. You'll start to recognize it, but basically when you have something on the bottom and the derivative of that something is on the top, that's ln form. So this turns into the ln of u, or the ln of sine y minus 2 plus c. Okay, so that's how I would get that one. Oh my goodness, this looks fun. Okay, theta squared plus secant theta minus 1 tangent theta minus 1 d theta. This is like kind of reverse chain rule. Also, it's kind of just, you should know how to integrate this, okay? Now think of theta as an x. If that bugs you, you know, you could say let theta equals x, but I'm going to try to work with this. The integral of theta squared is theta to the third over 3. And then right here, you guys, the integral of secant tangent. Well, I know that the derivative of secant is secant tangent. So the integral of secant tangent should be secant. And then I would do reverse chain rule, but since it's just 1 theta, you know, I don't really have to worry about that. If it was like a 2 theta or something, I would. Okay, there's that one. Okay, 4 over 2 plus square root of x dx. I haven't looked over all of these problems yet, so I'm just kind of seeing some of these for the first time. And I'm thinking I might need to stop and think for just a minute here. This might be tricky, u sub. I'm not sure, though. Du equals 1 over 2 square root x dx, which means dx is 2 square root x du, if I multiply that over. And up here, okay, let's see here. Up here, the square root of x is actually u minus 2. So the square root of x is u minus 2. So dx can change into 2u minus 4 du. I don't know. This is looking weird to me, but I am going to try it. Let's see here. Okay, so here's what I'm replacing. 2 plus root x, that's u. Okay. This 4 right here, I'm going to bring it out. All right, and then dx, I'm going to replace with this. All right, so dx is 2u minus 4 du. Hey, cool. I think that worked. Am I surprised? A little bit, but let's see. Now I can split the fraction. So 2u, if I split it this way, 2u over u is just 2. And then 4 over u, I'll go ahead and leave that as 4 over u, because then this becomes 2u and 4 ln u. And then u is 2 plus square root x. 2 plus square root x. Okay, plus c. I could distribute the 4 if I wanted to. So that's going to be 8, 2 plus square root x, minus 16 ln 2 plus square root of x, plus C. That's kind of fun. All right, very cool. Okay, guys, I'll take this opportunity to talk about something. As I'm going through here, I'm checking my work with, or just checking the answers with the answer key, make sure I'm not missing anything. Sometimes when I make these videos, right, I forget something, but I'm looking and I saw the answer key and it looked like this. It said, okay, and it gave me that. And I was looking at this and I was thinking, all right, is that the same thing? Well, look, okay, the plus C, all right, plus C, that's cool. The minus 16 ln of 2 root x, the minus 16 ln of 2 root x. And then when I distribute that, the plus 8 root x. So when the person that wrote the answer key did this, they like didn't have that 16 right there. So I'm asking myself, are those the same questions? Now, because there are multiple ways to do integral problems, and this person did it a little bit differently than I did it, but there are multiple ways to do it. Okay, why, you guys think about why are these answers are equivalent when they're clearly off by 16? Like that one is supposed to have a 16 plus, and that one doesn't. Why are these equivalent? Well, if you think about it, it's because the constant right here, it's a constant, and these constants are just different. So for example, maybe that constant is 1, then that constant would be 17, but they're still just constants, right? So every once in a while on a multiple choice question, you'll see something where like you integrated it and you got something, blah, 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 plus 2 plus C, and the answer doesn't have the plus 2 plus C, it just has a plus C. That's okay. It's like that constant got absorbed in that plus C at the end. Okay, so I just kind of wanted to mention that to you in case you see something like that on a multiple choice test. All right, let's check out these last two. Guys, the second I look at this, oh, it's tangent regular x, not squared. Tangent x minus 1 dx. I think to myself, well, shoot, I want to do u sub, and I want to let u equal tangent of x minus 1. And in my head, I'm already thinking, well, what's the derivative of that? Because whenever we do a u, we always looking for our du. Okay, well, derivative of tangent is secant squared. And guess what? A cosine on the bottom is the exact same thing as a secant squared on the top. So this is the same problem as if I were integrating e to the tangent of x minus 1 secant squared x dx. Okay? And when I do my u sub, here's what this turns into. E to the u du. So it's e to the u, which is e to the tangent of x minus 1. Okay, so there's another u sub right there. And then for number 10, let's see, I have sine of e to the negative t, e to the negative t dt. Definitely another u sub, because right here, if u is e to the negative t, the derivative of that is e to the negative t times the negative dt. All right, so it's a chain rule right there. So I have to put it times the negative, which means there's a negative on the outside. So this actually gives me the integral of sine u du. And I know the integral sign is negative cosine. So I have negative cosine u. Those two negatives become a positive cosine u plus c, and that's e to the negative t. Okay. Awesome. All right, now we're going to do some evaluating ones, and it might be more u sub, it might be more sine, like we'll see what we come up with here. Okay, so starting with number 11, and actually what I want to do also is, since these do have endpoints, let's go ahead and check every question on our calculator as we go through to make sure we do know how to put these in our calculator. Okay? All right. This is a fourth root of 3x plus 4 dx. This is definitely a u sub problem, where u is going to be 3x minus 4, and du is going to be 3 dx. Okay, so I've got my 3 and my 1/3, and I go like this. So this is going to be u, and the fourth root is u to the 1/4 du. the integral of that, 1/4 plus 1 is 5/4 over 5/4, which is times 4/5. And then I get 4 over 15. Now, at this point, I typically would go ahead and put my x back in, but since I'm evaluating it, so typically I would put that back in for you. I'm actually not going to put that back in because like it's already kind of complicated. But what I'm going to do is change my endpoints, okay? You guys see how right here, it started at -1, but that was an x value because that's what dx. What's the u value for -1? Well, if x is -1, u is -3 minus 4, that's -7, okay? And if x is 4, u is 3 times 4 minus 4, which is 12 minus 4, which is 8, okay? So that's what I got for that. So here's my final answer here. Okay, when I plug this in, I am gonna get 4/15 on the outside, 8 to the 5/4 minus -7 to the 5/4. Something looks bad about this. Oof, I did this whole part wrong. Okay, hold on. I didn't do this whole part wrong. I did my endpoints wrong. Did any of you guys catch it? Extra points if you caught it. The u sub was supposed to be 3x plus 4, which didn't change any of that, but it certainly changes this. So my endpoints are actually not 8 and -7. That's my bad. My endpoints are -3 plus 4, 1, and 12 plus 4. 1 and 16. That's a little bit better. 16 to the 5/4, 1 to the 5/4. Okay? Now on a free response question, you guys, I'm done. That's my answer. Okay, on a multiple choice question, let's see if I can get that to come down anymore. 16 to the 5/4 is the 4th root to the 5th. Now I happen to know that 16 is a perfect 4th because it's 2 times 2 times 2 times 2. So that's 2 to the 5th, which is 32. And the 4th root of 1 to the 5th, I mean, 1 is easy because it's just 1. So that's 32 minus 1. So that's 4 over 15 times 31. So that's 124 over 15. Okay? So that's if it was multiple choice, you'd have to go to that step. Now let's see how awesome I am and if I can get this on my calculator. All right. Okay. Here we go, here we go. Okay, remember that we get integrals under, let's clear this out, math 9. So this is the integral from -1 up to 4. Okay, and it's a 4th root, which you could just write to the 1/4 power. I'm actually going to do this root button right here under math 5, just so you guys can see how that works. So there's a 4th root of 3x plus 4 dx. And let's get this over into the screen here. If I change that into a fraction, I get 124 over 15. Let's go. That was amazing. All right. Okay. Let's see here. Let's look at number 12. All right. Looking like another u substitution one here, guys. I'm going to go ahead and let u equal what's on the bottom. So u is going to be 5 minus 2t. du, the 5 will go away. It'll be -2 dt. So I'll do a -2 and a -1/2. And then this becomes 1 over u du. We know that that is ln of u. And again, instead of plugging this in, I'm going to go ahead and convert my endpoints. I just think it's going to be a little bit easier. All right. So to convert my endpoints, I take 0 and I put it in here. 5 minus 2 times 0, so 5 minus 0 is 5. And then I take 2 and I put it in here. 5 minus 2 times 2, 5 minus 4 is 1. So it's negative 1/2. And then as I evaluate this top to bottom, it's ln1 minus ln5. Now, the ln of 1 is 0. So I could write this as negative ln5. Negative times negative is positive, so I'm thinking 1/2 ln5. Okay? Now, multiple choice, let's say they're being tricky. I think they'd probably just go ahead and write 1/2 ln5. But if they're being tricky, you guys, how could they write this? They could write it as ln of something. Well, do you guys remember that when you have a coefficient, it can come up and be an exponent? So it actually could be ln square root 5. Could be either one of those. Once again, though, let's go ahead and check this on our calculator. So we'll go Math 9. The original problem was the integral from 0 to 2. When I'm doing fractions, I like to do alpha y equals to get my fraction there. That way I don't have to worry about putting parentheses around the bottom and stuff. 1 over 5 minus 2x. I'm going to just use x because it's easier to find than a t dx. Now let's see, the first answer I got was 1/2. Let me make that a fraction again. Okay, 1/2 ln 5. Sweet, pretty accurate. What about ln square root 5? Let's go. Okay. All right, nice. You see how these are like mostly U sub? Honestly, that's kind of how it is. You like almost always try to do U sub before you do anything else. Okay. 2 to e cube root of ln of x over x dx, another U sub. U, I'm going to let this be the cube root of ln, and kind of the reason why is because the derivative of that is 1 over x dx. Pick some new colors here. So it's the cube root of u, and then all of that du. Now u to the 1/3, when I integrate that, becomes u to the 4/3 over 4/3, which is times 3/4. And I think I'm going to change endpoints here. All right, I'm going to go ahead and change my endpoints here, guys. Now check this out. I'm going to do e first because it's easy. The ln of e is 1, okay? I'll do 2 next. The ln of 2 is ln 2. It's not like a thing. All right. So when I do this, it's going to be 3/4, and then it's going to be 1 to the 4/3, and then it's going to be ln of 2 to the 4/3, which I want to tell you something really quick. That is different than that. Okay. Those two things are different. And here's why it matters. This you can bring down in front. This, you can't do that. All right. Anyway, so that's pretty messy, and I think that that's probably how I'm going to leave that. I mean, the 1 doesn't have to be to the 4/3. So it could just be like 3/4. And it can be 1 minus ln of 2 to the 4/3. Okay? So how do I check something like that? Well, when I put it in here, okay guys, so I go 2 to e. Here's one place I can find it on the calculator. It's right above the divide by sign. You can also use that e, but that's usually e to a power. So, okay, 2 to e. And then the original problem was, let me make it into a fraction. Let me make it into a cube root of ln of x over x dx. Okay? Now let's see if that's what I got. I got 3/4. And then let's see, I got in parentheses 1 minus, another parenthesis, ln of 2, close that, to the 4/3. Oh, that's not right. To the 4, hang on a second. 4/3. Boom. Let's go. All right, cool. So I can even check and make sure I'm getting that right. But practicing it on your calculator, I can't stress enough, helps you figure out where the buttons and stuff are, and that's really, really helpful. Okay, guys, even for just like your ACT or, you know, anything like that, not just the AP test. Okay, let's do 14. This is a pretty good one. I don't know if you guys remember, but do you remember that the derivative of e to the x is e to the x? And the derivative of a to the x was a to the x times ln a. That means the integral of e to the x is e to the x. And the integral of a to the x is a to the x divided by ln a. Okay? So this is 3 to the negative x divided by ln 3. Also, though, a reverse chain rule, because there is a negative there, I got to divide by a negative. So just don't forget that part, okay? But otherwise, those are those rules that you'll need to remember. All right, let's see. Okay, I'm going to evaluate this 1 to 0, which I can use that because I didn't change it to use or anything, okay? Now, what I like to do, I don't know, guys, this is like kind of just me, but all that is a constant. The 3 isn't, but the negative ln 3, that's a constant, okay? So then I can do it like this, 3 to the negative 1 minus 3 to the 0. If I was free response, I'd be done. If it's multiple choice, 3 to the negative 1 is 1/3, 3 to the 0 is 1, and then 1/3 minus 1 is negative 2/3. So I guess my final answer would be positive 2 over 3 ln 3. That's what my guess would be that they would put on a multiple choice test. Hang on a minute. Negative 2/3, positive 2 over 3 ln 3. Yeah, that's right. Okay, so let's check this out then and see if we got this. Here we go. All right, integral is 0 to 1. Type this in with me. Don't just watch. It doesn't really help you guys if you're just watching. 3 to the negative x, oops, dx. And we're going to say, is that the same thing as fraction 2 over 3 ln 3? Okay, very cool, very cool. All right, let's keep on going. Okay, for number 15, the sine of 2x dx. I mean, you could do this as a u substitution, but to be honest with you, the fastest way to do this is the reverse chain rule, because we know that the integral of sine is negative cosine, and when we take a derivative, we multiply by 2. When we take an integral, we do a 1/2. So I feel like that's kind of easy enough here. Okay, when I plug this in, that becomes the cosine of 2 pi over 4, which is cosine pi over 2. When I plug this in, that becomes cosine 0. Don't automatically make the mistake of thinking, oh, anytime I plug 0 into something, it's 0. That's not true once we get to trig functions, okay? All right, the cosine of 1/2 is actually 0. The cosine of 0 is 1. So I get negative 1/2 times 1, or 1/2. All right, let's see if this will go in here real quick. Math 9, 0 to pi over 4, and then it's sine of 2x dx. Sometimes I just do this at the end, math 1, and see if it'll just do the whole thing and turn into a fraction for me. And it did. So very cool. All right, perfect. Okay, let's see, for 16, 3, let's see here, cosecant, cotangent, oof, so many t's in there, 3, cosecant t, cotangent t, dt. Okay, you guys, this is just a regular integral. Cosecant, cotangent, the integral of that is negative cosecant. Yeah, negative cosecant. Okay, so by far the hardest part of this question is being able to plug these in. But, all right, check this out. On a free response test, minus cosecant pi over 6. Boom, you're done. All right, we did evaluate it. It didn't say I had to figure out what cosecant of pi over 3 is. We just, could leave it like that. Okay, however, on a multiple choice, it's going to simplify that down. So let's just try something real quick here. If I can figure out the sine of pi over 3, I could figure out the cosecant of pi over 3. And if I can figure out the sine of pi over 6, I could figure out the cosecant of pi over 6. Well, if I look at my handy dandy trig chart, sine of pi over 6 is a half. Sine of pi over 3 is root 3 over 2. Okay, so let's get back over here. So sine of pi over 6 was a half, so that's 2. That's root 3 over 2, so that's 2 over root 3. Okay? So here's what I'm thinking. Negative 3, and then that's 2 over root 3 minus 2. I don't know, like, how much farther they're going to simplify that. Are they going to rationalize it? Like, probably not. That, looks all right to me. We could distribute that and say it's negative 6 over root 3 plus 6. And then, I mean, really, if you had to rationalize, if that wasn't the answer, and you had to keep going, and then you'd be like, oh, stupid AP graders, stupid AP question writers, or whatever. And we do this, and we go, okay, well, that's negative 6 root 3 over 3 plus 6, which is negative 2 root 3 plus 6. So if I had to simplify that all the way down, I could. Okay. All right, one more integral. We'll move on to our next section. This is from square root 3 to 2. All right, and hopefully you guys recognize this. This is inverse sine form. Now remember, the inverse sine form looked like this: a squared minus u squared. Okay. And I have to find u, du, and a. Well, u squared means that this is something squared. Well, I know x squared is x squared. 1/4 is what squared? 1/2. Do you see how that? I have to think of that as 1/2 x squared. It'd be the same idea as if it was like 9x squared. You have to think of it as 3x squared. Same idea, okay? When we're doing inverse tan and inverse sine forms. All right. So u is 1/2 x, du is 1/2 dx. So I go 1/2 2. A is just a 1. All right. And okay, inverse sine form looks like this. Okay, well, actually, hold on. Let me just go ahead and write this. That becomes du. So this is 1 over 1 minus u du, which is inverse sine of u. So it's 2, and then it's inverse sine of 1/2 x. Okay? Okay, now, let's evaluate this, and I don't have to change my endpoints. So I'm going to use 2 and root 3 because I plugged back in the 1/2 x. Okay, so I'm going to leave the 2 on the outside. Okay, when I plug this in, you guys, I get inverse sine of 1/2 times 2. Sorry, 1/2 times 2 is 1. And inverse sine of root 3 over 2. Okay? And so when I'm evaluating this, again, that's a trig chart thing. Inverse sine of 1, inverse sine root 3 over 2. Okay, so let's see here. Inverse sine of 1, that's going to be over on this side of the graph, you guys. And sine is the y coordinate. So where does the y coordinate equal 1? Up there, and that's pi over 2. And then inverse sine of root 3 over 2, that's pi over 3. Okay, so this is going to be inverse sine 1 is pi over 2. Inverse sine root 3 over 2 is pi over 3. If I distribute the 2 through, that'll just give me pi minus 2 pi over 3, which is like 1 minus 2/3, so it's 1/3. So that's pi over 3. Okay? Whew, all right. That was a lot. I'm going to go take a break. I suggest maybe you do the same if you have time, and then we're going to come back and continue working.